Welcome to an introduction on thermodynamic key terms. We're going to start by talking about what a system is. So a system is any part of a thing that you want to kind of look into some more. So there are two types of systems, and we'll start by talking about what a closed system is. So imagine some sort of thing that we're trying to look at. We're going to give this thing a boundary to separate it out from its surroundings. And surroundings is just anything outside of the boundary. And what makes the system closed is that mass cannot enter or exit the system. However, energy can enter and exit the system. And energy can be in the form of heat, mechanical, or electrical energy. Let's take an example. So imagine a can of beans. This can has some beans in it. And we'll take the system to be the can of beans with a boundary of the can itself. And the surroundings, just everything not inside the can. So, because this is a closed system, beans, which have mass, cannot enter or exit the system. However, if we put this can of beans directly on a stovetop where it's emitting heat, after a while, heat will go into the can of beans and make these beans into hot beans. And if we took the beans off of the stove and put it on a cool place, cool area, the heat from the can of beans will go back into the surroundings. And so this energy transfer is happening inside of the closed system. Let's move on to talk about the other type of system. And you would think that it'd be called open, but instead it's called control volume. And similar to a closed system, control volume systems also have a boundary and a surrounding. The only difference is that mass can enter and exit the system. And energy can still enter and exit the system in the form of electrical, mechanical, or heat energy. Let's take an example of a control volume system. So let's imagine a water fountain. The water fountain has a little spout, and the spout shoots out water on the press of a magical button. So our system is the spout, our boundary is the plastic or metal surrounding of the actual spout, and our surrounding is everything else that's not the spout itself. So water is actually entering the spout through plumbing pipes, and this water has mass. And then water is also exiting the spout, or our control volume, into someone's mouth, or a water bottle, or a cup. Now let's imagine that this whole water fountain is outside. So here's our beautiful sun, and this sun is emitting heat, and it's heating up the air surrounding the spout. Then the heat is going to go into the spout, And so this energy is going into our control volume. And later in the day, we can imagine that there are some clouds that get formed. So the air becomes a little cooler. And heat can also exit our control volume. Great. This is all done with systems. We'll move on to thermodynamic properties. And thermodynamic properties are just really a fancy name. So thermodynamic properties. They are macroscopic, numerical, characteristics of a system. So, for example, mass is one thermodynamic property. Volume is another thermodynamic property. Temperature is another thermodynamic property, and so is density. And thermodynamic properties can be split into two different types. So one is called extensive properties. So these extensive properties depend on size. They scale with size. The other type is called intensive thermodynamic properties, and these don't depend on size. And what I mean by depend on size is if we take our example of a can of beans. I just love can of beans. So here's a can of beans. And here are our beans. Within the system, if we choose some beans, so let's choose a few beans. If we change the number of beans, let's say we increase the number of beans, then the mass will also increase. If we decrease the number of beans, then the volume will also decrease. However, if we take some beans and we increase the number of beans, the temperature, as long as all the beans are at the same temperature, will stay the same. Stays constant. And similarly, because density is mass over volume, density will also stay the same, even if you increase or decrease the number of beans. And one thing to note is that if you take two extensive properties, so let's just call this extensive property 1, and divide it by another extensive property 2, then we get an intensive property. And you might have noticed this when we were talking about density. So density, recall, is mass over volume. But mass and volume are actually extensive properties. Let's take this one step further. So let's take 1 over the density, which is equal to 1 over mass over volume. And 1 divided by fraction is just the reciprocal of that fraction. So 1 over density is equal to volume over mass. And this is known as specific volume. This keyword specific with a funky P will come on later as well. And it just means to take this word after specific and divide it by mass. So in this case, we take volume, right, and we divide it by mass. That's it for some key terms. Next video, we'll look into the ideal gas law and we'll apply it to determine the mass of air in a standard classroom.